Howdy, folks. This is Mr. Recorder. Today's lesson is about parent functions. A lot of families usually have common characteristics that are shared between the family members, and the same is true when we talk about function families. They're basically just groups of functions that have key characteristics that are the same. The most basic of any family of functions, that most basic function, is called the parent function. Every other function in that family is what we call a transformation of the parent function. Transformations can be sliding to the left, right, up and down, reflecting like a mirror, stretching in different directions, so changing the shape or location of a graph. So let's look at some info here. One of the families is the constant family, constant function. They look like this. F of x equals a number. And if you remember from graphing, f of x is y, right? Y equals f of x equals 1. So this, y equals 1, that's the graph of a horizontal line where all the y values of these points are 1, right? Over 0, up 1. Over 1, up 1. Over 2, up 1. All the points on this line have a y value of 1. So this is what we call a constant function, because the value of the function, which is the y value, right? F is the function, y is f. That function value always stays the same. It's always 1. So that's why we call that a constant function. The domain, which is all the x values for which the function is defined. So basically all the x values that this function has a graph for. All real numbers. You go to the left forever, you go to the right forever. So all x values count. But the range, there's only one y value. So the range is just y equals 1. Then we got the linear family. The linear family looks like this. F of x equals x. That's the parent function. But you might recognize, you've seen like y equals mx plus b, and those are line. That's the equation of a line in slope-intercept form. But you'll notice that it has x. In this one, there was no x over here. So if you're just looking at the equations, you can tell a constant family equation or function from a linear family function, because the constant function will not have the variable. It'll just be a number. No x. The linear function has an x in it somewhere, right? Something times x plus something, but it has an x. And those graphs look something like this. F of x equals x. That has a slope of 1 and a y-intercept of 0. So the slope of 1, you go up 1 when you go over 1. The y-intercept of 0. And so all these, well, you might say, well, wait a minute. Linear, right? Well, this is a line. But the reason we use the word linear is to describe the way that the function values are changing. Here, when we change different x values, the function value remains constant. On this one, any line that's tilted, that's non-horizontal, as x changes, y changes. Right? As you go over some, you're going to go up some. This slope tells you how that changes. And so if this is not 0, that means we have an x, and then we have a slope. So our y value, our function value, is changing as our x value changes. This goes all the way to the left, all the way to the right. So all real numbers are in the domain. And then y values, this goes up forever and down forever. So the range is also all real numbers. So the next family is absolute value functions. Parent function is f of x equals absolute value of x, but you could also have it, really be like mx plus b, or whatever you want to call those. You could call it a times absolute value of x plus b, but either way, it's kind of like a line. It's kind of like the linear functions, except for what happens when the x values are negative, right? Because the absolute value of a positive number is that same number. So if x is positive, absolute value of x is just x. So that part over here, where x is positive, looks exactly the same as absolute or f of x equals x. But what's different is when x is negative. When x is negative, over here, the y value was just the same as the x value. So when we were at -1, our y value was -1. Over here, when x is -1, what's the absolute value of -1? It's 1. So this end of the line is also going upward because of the absolute value part. Our output values, our function values, are going to always be positive. Greater than or equal to 0. It could be 0. And actually right here it is 0. Absolute value of 0 is 0. So absolute value functions are V-shaped. The domain, we go all the way to the left and all the way to the right, so that's all real numbers. But the range, there's no graph down here. There's no graph below the x-axis. So our range is only those y values that start here and go up forever. So that's y greater than or equal to 0. So the last family that we're going to talk about is the quadratic family. And so you'll notice with a quadratic that you have x to the second power. And you have to have x to the second power to have a quadratic, and you can't have x to any higher power than 2. Otherwise it wouldn't be a quadratic anymore. So the x squared being the highest power of x is what you look for in the equation to identify a function in the quadratic family. So y equals x squared is just a standard parabola, and it's U-shaped. Okay, so absolute values are V-shaped graphs, and quadratics are U-shaped graphs called parabolas. The domain, this parabola, even though it looks like it goes up and it might stop somewhere, if you think about it, you can square a number no matter how big it gets or how big negative it gets. Negative a bajillion, you can square that and get a positive bajillion squared. But either way, you can go as far left as you want and still square that number. You can go as far right as you want and still square that x value. So the domain is all real numbers. But the range, just like with the absolute value parent function here, there was no graph below the x-axis. Same thing with the quadratic, so it'll have the same range. It's just 0 and up, so y greater than or equal to 0. And now to the extremely difficult example problem. Number 1. Identify the function family to which f belongs. So here's the graph of f, and f of x is 2 times absolute value of x plus 1. Hint, hello, absolute value. Compare the graph of f to the graph of its parent function. Okay, so since it's V-shaped, and we see the absolute value right here, we can conclude that since it's V-shaped, it's an absolute value function, so it's in the absolute value family. Alright, so what is the parent function? The parent function would just be absolute value of x, which is like so, right? -1, up 1, -2, up 2, over 1, up 1, over 2, up 2, and so forth. Alright, now let's describe f of x in terms of the shape of the parent function. So it looks like, you can see like the vertex of the V is up, shifted up. And then on the parent graph, when you go over 1, you go up 1. But on this one, when you go over 1, you go up 2. So this graph, the appearance is more narrow. And it's also shifted up a unit. So the graph is shifted up and is narrower than the graph of the parent absolute function. We can compare the domain and range as well. The domain of each function is all real numbers because they both go all the way left and all the way right. The range of f, the blue one, is just the y values greater than or equal to 1. And the range of the parent function is all the y values greater than or equal to 0. So the range of f is y greater than or equal to 1. The range of the parent absolute value function is y greater than or equal to 0. Example number 2. Identify the function family to which g of x equals 1/4 times this squared quantity, x minus 3, that quantity squared. What function family does that belong to? And compare the graph of g of x to the graph of its parent function. Well, this has a squared here with an x inside of it. If you remember, this means really x minus 3 squared means x minus 3 times x minus 3. You would FOIL that and get x squared minus 6x plus 9. So now you can see that the highest power of x is x squared, even though we're just looking at it in this form. So the parent function would just be x squared. That's quadratic. But I don't see a picture of this graph, so what shall I do? Oh, that's a good idea. Welcome to my favorite graphing calculator. So I'm going to type in here f of x equals x. This little button right here, we'll put a squared. So there's my parent function. And then g of x equals, what was it, 1/4? So I'm just going to do 1 divided by 4, push my right arrow to get out of the fraction, parentheses, x, what was it, minus 3? Close the parentheses, make that squared. So let's take a look at these. Here's my parent function, and here is my child function, my baby function. It looks like it's wider, right? And it's also, if you look at the vertex of this parabola and the vertex of that parabola, it's been shifted to the right. And what else? They're both U-shaped, right? So basically, the graphs kind of look like this. This is my special hand-drawn graph of awesomeness. This arrow here was a little jacked up. I made this one first. That's why it's so tall, because I ran out of graph over here. Should have maybe made it that tall to be even cooler. Anywho, these are my two graphs, and here's how I answer this question. The graph of g is U-shaped, so g is a quadratic function. The graph of g is shifted right and is wider than the graph of the parent function. The domain of each function is all real numbers because they both go left and right all the way. And the range of each function, they're at the same height. So the range of each function is y greater than or equal to 0. All these y values from 0 on up are part of the range. So while you're working on the practice problems for this dealio, for these parent functions, look for patterns. Look for patterns on like when it's wider or narrower and which way it moves based on what these numbers are. See if you can come up with an idea of how these numbers change the shape of the parent function graph. Talk to you later. See you soon.